Now we are on the OR part of question number 30, which says 30B. It says AB is a chord of a circle with center O, and so O is the center and AB is the chord of the circle. Further, we are also given the measurement of this angle, and that is angle AOB is given as 60 degree. This is given as 60 degree. And OA, which is nothing but the radius, is given as 14 centimeter. So that means this is also 14 centimeter. Well, it's not needed to write. Anyway, I wrote it. What we have to find out is the area of this minor segment. That means you have to get this area of this minor segment. Now, what you can observe here that from area of this minor segment, once again, that how do we get the area of this segment? Like if from this area of this sector, right? From the area of this sector AOB, if you subtract the area of this triangle, right? If you subtract the area of this triangle, we get the area of this segment. Now, to find out the area of this segment, we as I said, it should be what? The area of segment is equal to area of sector minus area of the triangle. Now, what's the area of the sector for the, if I write the formula, it is theta over 360 into pi r square minus. And now what else you have to know that this is an isosceles triangle. An isosceles triangle whose vertex angle is 60 degree is an equilateral triangle. So this is an equilateral triangle, and the formula for area of an equilateral triangle is root 3 by 4 a square, where the a is the side. Now let's plug in the value here. The theta, which is 60 degree, mentioned here over 360. The value of pi is not mentioned, so we'll take 22 over 7. And r is 14, right? So it's 14 square. Minus this is going to be root 3 by 4, and a is the side, and the side is nothing but the radius here, which is 14 again. Now I can say that I can take 14 square as common, or let's first reduce it. I can see that this is divisible by 6 times. And further, this is 3 times. And this is by 2, right? It's 6 times. 2, 3 times. Oh, this is 11. 2, 3 times and 2, 11 times. What else is there? If we have 14 as common, so I can take 14 square as common, right? So what we are left with 11 from here, and this is 21. Yeah. Minus the value of root 3 is mentioned, so we have to get the answer, replace root 3 with this over 4, as I have taken 14 square as common. So this is 196, and we have to take LCM. The calculation is going to be cumbersome. This is the LCM, that is 84. That should be 84. So it should be what? 44 into 11 is 44. We'll have to get 21. So I'll be using calculator here. You have to do it. So 1.73 into 21. It's coming 36.33. Further, I can see these are divisible. This is 14, 5 times, 6 times. And this is 14. How much times? 14, 14 times. Okay, that's 14. 14 times, I suppose. Yeah, that's 96. And 14, 6 times. Right, I can reduce it further. This is 2, 3 times and 2, 7 times. So we have 7 over 3 outside. And from here, what we'll get, this can be done easily. This is 44 minus 36.33. So it'll give you 7.67. Yeah, this is, I can reduce it by 7. Is it 7? How can it be 7? It's what, 44, right? Yeah, that should be right. 44 minus 36.33. Yeah, that's correct. This is 7.67. Now I'll reduce it further. This is 3 1 times, 3 1 2 times is 6, right? And remainder 1, 16. So 5 times is 15 and 17. Let's make it round off to 16. So what I did, I divided it by 3 and we are getting 2.55 something. So I rounded off to 56. And if I multiply this further with 7, right? So it is 2.56 multiplied by 7 should give you 17.9292 centimeters square. So the area of the minor segment here is 17.92 centimeters square. That should be the final answer.